the pulse beneath the ice. The night over eastern Greenland was silent enough to feel alive. The air hung motionless and brittle at 40 below, and the stars above were sharp and unmoving, as if frozen in the same ice that covered the world below. The only sounds were the faint groans of shifting frost and the hum of buried machinery far beneath the surface. Deep under nearly 2 kilometers of ancient glacial crust, an array of instruments listened to the planet's hidden vibrations. The European Cryo-Array was one of humanity's most sensitive observatories, not aimed toward the stars, but toward the Earth itself. It listened for the planet's quietest murmurs, magnetic fluctuations, seismic ripples, and the subtle electromagnetic rhythms that passed through the mantle like distant breathing. For years, the data had been nothing but noise, random patterns of natural origin, statistical chaos. Then, one night, that chaos began to form a rhythm. 3 precise pulses. Pause. 3 pulses again, each separated by exactly the same interval. And repeating. Dr. Lena Voss, a young researcher stationed at the Cryo-Array Control Lab, noticed the pattern during a routine data sweep. At first, she assumed it was interference, a calibration echo, a looping artifact from the signal filters. But every diagnostic came back clean. The pulse wasn't coming from the instruments. It was coming through them. The deeper she traced the data, the stranger it became. The pulses were perfectly uniform, each lasting exactly 3 microseconds, with harmonic frequencies at 5, 8, and 13 Hz, a Fibonacci sequence. Nature rarely produces such mathematical symmetry, and certainly not beneath 2 kilometers of solid ice. She cross-checked the readings against every known source of noise. Solar wind, geomagnetic storms, cryoseismic movement, even local atmospheric activity. Nothing fit. Then, reports came in from other monitoring stations across the polar network, from Svalbard, Tromsø, and even McMurdo in Antarctica. Each had detected the same repeating pulse, identical down to the millisecond. Whatever was transmitting wasn't local. It was global, and it was resonating from deep beneath Greenland's ice. When the data were triangulated, the coordinates pointed to an empty region in the heart of the East Greenland ice sheet, a place with no stations, no geothermal activity, and no recorded geological anomalies. Just ice, frozen, ancient, and silent. But not silent anymore. The signal continued for hours, at first steady, then shifting, as if it were testing its own reach. Every few cycles, one of the 3 pulses would arrive slightly out of phase, a microscopic delay that formed a slow, deliberate modulation, not random noise but adaptation. It almost felt like response. Lena's supervisor joined the feed from Copenhagen. His voice was calm, but the weight in it was unmistakable. "If this isn't an instrument fault," he said, "then we're not recording geology. We're recording behavior." "You mean it's artificial?" she asked. "I mean it's organized." And then, as suddenly as it had appeared, the pulse stopped. No fade out, no interference. Just silence, clean and absolute. For the rest of the night, the instruments listened. Nothing returned. Later, as she compiled the report for transmission to ESA headquarters, Lena hesitated before adding one final line to her notes. Not for the record, just for herself. "If the planet has a heartbeat, we just heard it for the first time. The pattern that shouldn't exist." The cryo-array logs were uploaded to the ESA servers in Darmstadt before dawn. Within 6 hours, the anomaly had reached half a dozen research institutions across Europe, quietly, unofficially. A few astrophysicists, a handful of geophysicists, and one data architect at the Max Planck Institute, all whispering through encrypted channels. None of them could explain it. Coherent, repeating pulse, perfect mathematical symmetry, and a confirmed subglacial origin from one of the quietest places on Earth. By midday, the signal had earned a name inside the ESA database. Lumina Sequence 1A. It was labeled non-terrestrial in structure, but terrestrial in location. The first detailed analysis came from Dr. Omar Laghari, a Pakistani mathematician specializing in low-frequency resonance. He noticed that the waveform of the pulses wasn't random noise or even a simple tone. Each triplet contained a microvariation in amplitude, a pattern that, when expanded and normalized, resembled an encoded modulation, not a sound, a message. He overlaid the harmonics in 3 dimensions, and what emerged looked eerily like interference fringes, the kind created when multiple coherent sources overlap. Except there was only one source, or so everyone believed. Ligari's conclusion was cautious but unnerving. The signal behaves as if the Earth itself were a resonant cavity, transmitting feedback through its own magnetic lattice. When he presented his findings during the internal ESA briefing, someone in the room whispered what no one wanted to say out loud. It's as if the planet is replying to something. 2 days later, a second pulse was detected. Not identical, similar, weaker, fragmented. This time the source seemed displaced several thousand kilometers south, somewhere beneath the North Atlantic Ridge. The pulse sequence was shorter, only 90 seconds, but the same May 8, 13 harmonic structure was present. And then, for the first time, there was an addition. A faint echo delayed by nearly 1 full second. A mirror image of the signal inverted in phase. In the world of physics, that shouldn't be possible. A reflection of a subglacial, low-frequency resonance wave implies the existence of a second emitter, another point inside the Earth that can both receive and transmit the same coherent signal. Lena Voss saw the new data appear on her console as the satellite relays updated. She didn't say anything. She simply stared at the waveform, feeling that same rhythmic weight in her chest, the memory of the first pulse. It was slower now, almost tired, but it was there. The ESA containment protocol was activated. All raw data on the Lumina sequence was locked behind a secure tier, accessible only to the Helios Division, a small classified task group created for planetary monitoring anomalies, usually asteroid impacts, gamma-ray bursts, or magnetospheric disruptions. This wasn't supposed to include the Earth itself. Officially, nothing had happened. No statement, no acknowledgement, no leaks. But secrets are fragile things. A graduate student at the University of Helsinki, working on magnetotelluric cross-correlation data, found traces of the Lumina frequencies buried in her dataset, 3 repeating pulses with perfect harmonic ratios. She posted an image of the waveform to a private research forum. Within hours, it was copied, renamed, and spread across anonymous channels under a single phrase. The Earth is talking. That night, dozens of amateur radio astronomers tried to listen. Most found nothing, but a few, using ultra-low frequency receivers, picked up an odd, rhythmic hum barely above the noise floor. A slow, distant vibration that seemed to rise and fall with the planet's own magnetic field. Meanwhile, deep inside ESA's cryo-array servers, the machine learning algorithms designed to classify geological patterns began to behave strangely. Without instruction, they started grouping unrelated seismic records from across the globe under a new, automatically generated tag. Sequence Class L. The AI had found correlations no human had seen, matching microsignatures from Iceland, Chile, the Indian Ocean, and even under the Siberian permafrost. Each one carried fragments of the same harmonic ratio. Each one pulsed in the same impossible rhythm. When the engineers realized this, the AI had already gone further, extrapolating the pattern forward in time, predicting when and where the next resonance would occur. Its projection pointed to a new location, the South Pacific, near the Tonga Trench. The countdown it generated ended in 5 days. Lena barely slept. She reread the AI report, then the raw data from Greenland. There was something she hadn't noticed before. A faint modulation hidden beneath the main pulses, almost like a secondary channel. When she isolated it and increased the gain, a strange interference pattern appeared, one that translated almost eerily into a visual grid. She rendered it, a lattice of interlocking arcs, converging toward a single geometric node. Not random, not natural, a structure. The cryo-array computers labeled the output automatically. Anomaly subchannel detected. Possible intentional encoding. Her breath fogged the glass of the monitor as she leaned closer. The pattern looked familiar, like a map, but not of the surface. It resembled something deeper, something beneath. In the following hours, a quiet directive circulated through ESA and NATO research channels. All data related to the Lumina sequence is now classified under Project Aurora. No public disclosure, no civilian access, no communication outside the closed loop. But the silence would not hold for long, because somewhere in the South Pacific, the Earth was preparing to pulse again. And this time, it wouldn't just be heard, it would be felt. The resonance field. 5 days after the second signal, the planet trembled. Not violently, not enough for the world to notice, but just enough for those who were listening to feel it. A faint, synchronous vibration, measurable across dozens of seismic arrays from Iceland to New Zealand. The wave did not move through the Earth. It moved within it, as if every layer of the planet were briefly resonating at the same frequency. Inside the ESA's Helios division, researchers watched the monitors flicker with data they didn't understand. The predicted coordinates from the cryoarray's AI had been accurate. The new pulse originated near the Tonga Trench, deep in the Pacific Ocean, nearly 11 kilometers below the surface. It lasted 42 minutes. The same Fibonacci harmonic structure. But this time, there was a change, an additional harmonic at 21 Hz, double the previous upper limit. The Earth's magnetic field responded instantly. Satellites in polar orbit registered a subtle but distinct oscillation, a measurable dip in the magnetosphere stability. And for a brief moment, less than half a second, there was a global electromagnetic spike that interfered with high-frequency radio transmissions across 3 continents. To most of the world, it passed unnoticed. But in the sealed laboratories of the Helios division, the readings were impossible to ignore. The Lumina signal had evolved. Dr. Lena Voss watched as the model updated in real time. The wave now carried layers, a fundamental tone, its harmonics, and a new modulation pattern that rippled like interference. When she slowed it down and converted it into audible range, it produced a low, metallic hum, unsettling, almost organic. A pulse that felt alive. She wasn't alone in thinking so. Dr. Laghari, the mathematician who had first identified the encoding pattern, ran his own independent reconstruction. When he overlaid the first, second, and third signals, he realized something terrifying. The phase shifts between them were not random. When aligned correctly, they formed a continuous waveform, a single message stretched across space and time, transmitted piece by piece through the Earth's own crust. It's cumulative, he told Lena in a private video call. Each pulse builds on the last. Whatever it is, it's not repeating. It's progressing. By now, several anomalies had begun to appear around the globe. In Siberia, magnetometers began to show periodic fluctuations matching the Lumina frequencies. In Chile, deep-bore seismographs detected harmonic tremors that didn't correspond to tectonic movement. Even oceanographic buoys in the Atlantic started registering rhythmic pressure changes synchronized with the new pulse. The pattern was spreading, but the energy source remained a mystery. No volcanic, geothermal, or tectonic mechanism could explain coherent, planet-wide resonance at these frequencies. The only possible conclusion, one no scientist wanted to write down, was that the signal was being generated from within the Earth's structure itself. At the next Helios division briefing, Director Halder asked the question that had been quietly haunting everyone. If the Earth is transmitting, who or what is it transmitting to? No one answered. Late that night, Lena returned to her workstation. She opened the latest dataset from the Tonga pulse and isolated the 21 Hz band, the new harmonic. When she mapped its modulation visually, the same geometric pattern reappeared. Interlocking arcs converging into a lattice. But this time, the image wasn't static. It was rotating, slowly, methodically, as if completing a motion that had begun with the Greenland signal. She overlaid the previous 2 geometries, Greenland, Atlantic Ridge, Tonga, and froze. When combined, they formed a nearly perfect spherical grid. a structure encasing the planet, a resonance field. Her computer automatically labeled the file. Global harmonic shell, partial reconstruction, 72% correlation. Across the Pacific, an undersea fiber optic relay near Samoa suddenly failed. The technicians who examined the logs found that the failure coincided precisely with the moment of the last Lumina pulse. The optical sensors had registered a brief burst of light, internal from within the cable, even though no signal had been transmitted at that time. A spontaneous emission, light where there should be none. At the same moment, in Greenland, one of the cryo-array subglacial sensors, the same one that had first detected the anomaly, recorded a brief but measurable temperature increase. Only a fraction of a degree, but in a place that had been frozen for tens of thousands of years, even that was enough to matter. Within days, strange secondary effects began to surface. Compass readings near the poles became erratic. Bird migration data shifted. A handful of deep ocean monitoring stations reported unexplained acoustic voids, regions where sound simply vanished, absorbed rather than reflected. The Helios Division's analysts finally gave the phenomenon a formal name: the resonance field. Their internal report summarized the situation in a single sentence. The planet is developing a coherent, self-sustaining vibrational network of unknown origin and purpose. But Lena, staring at the data late one night, noticed something else, something chilling. The periodic intervals between pulses, once constant, were now shortening. The next predicted resonance was not months away, not weeks, just 3 days. The countdown began quietly, a low hum invisible to most of the world, but present in the instruments, and in the bones of those who listened too closely. Somewhere deep beneath the planet's crust, something vast was stirring. And for the first time in recorded history, the Earth wasn't just echoing life. It was preparing to speak. The awakening frequency. By the time the world finally noticed, the signal had already been there for hours. It began just before dawn over the Pacific, invisible, inaudible, but not unfelt. Satellite telemetry picked up a global shimmer, a fine distortion rippling through the ionosphere like heat over asphalt. The pattern expanded outward in concentric rings, circling the planet every 12 minutes. No one at first connected it to the Lumina anomaly, not until the light began. In northern Chile, astronomers at the Paranal Observatory reported an optical event so strange that every telescope on site stopped its scheduled observation and turned toward the horizon. For a brief 87 seconds, the night sky shimmered, not with auroras or atmospheric refraction, but with something that looked like structured light. Bands of pale, pearlescent color undulated in a precise, rhythmic pattern, pulsing at exactly 21 Hz, the same frequency the Helios Division had identified days earlier. It was as if the air itself were resonating with the planet. And then it stopped, instantly, leaving behind silence and a faint metallic taste in the air. Thousands of kilometers away, the same phenomenon appeared above Iceland, Namibia, and parts of the Indian Ocean, perfectly synchronized, perfectly timed. Every location formed a vertex on the same geometric grid Lena had reconstructed, the global resonance shell. At the Helios Division Command Center in Darmstadt, the Situation Room dissolved into controlled chaos. Data feeds from around the world flooded in magnetometers, seismographs, ionospheric monitors, all registering simultaneous, repeating oscillations. Every instrument that could measure frequency was singing the same note. The planet itself was vibrating. And not randomly. Dr. Lena Voss stood at her console, staring at the screen that displayed the aggregated field map. It looked like a living neural network. Vast, shifting, pulsing with bursts of energy that connected the oceans, the crust, the atmosphere. Every line of the network converged on a single point, the Mariana Basin, the deepest known point on Earth. "The signal is converging," she whispered. "It's not broadcasting anymore. It's listening." The new pulse arrived 8 hours later. It wasn't a faint hum this time. It was a wave. Seismic arrays registered a resonance magnitude of 6.8. Not an earthquake, but something close. The vibration propagated through the crust at the speed of sound, reflecting off tectonic boundaries and returning in perfectly timed echoes. Every return built upon the previous one, amplifying the field, feeding it. Energy without decay, self-reinforcing. In the Pacific, deep-sea microphones picked up an acoustic signal unlike anything ever recorded. Low, harmonic, and unmistakably patterned. The sound translated into audible range resembled a slow, thunderous heartbeat. Each beat aligned precisely with the 21 Hz oscillation. For the first time, the Lumina field was audible to the human ear. Within hours, unexplained electromagnetic disruptions began affecting the grid. Navigation satellites drifted off course by microseconds. Long-range radio systems reported harmonic interference that perfectly matched the Lumina frequency. Even consumer electronics began to behave erratically. Compasses spun, watches reset, phones rebooted spontaneously when near magnetic north. The news cycle struggled to contain it. First came the headlines: global magnetic storm, solar activity unusually high. Then, when solar readings failed to match the disturbance, came the speculation. Unidentified geophysical phenomenon spreads worldwide. By nightfall, footage from around the globe flooded social media. Shimmering lights above oceans, strange patterns in cloud formations, faint vibrations in the ground that people could feel through their feet. Humanity, for the first time, was witnessing the Lumina anomaly with its own eyes. Back at Helios, panic and fascination warred in equal measure. The modeling teams had discovered something new. As the resonance field expanded, it was beginning to affect local gravity. Not much, mere microvariations measurable only with precise instruments, but enough to prove that the field wasn't purely electromagnetic. It was coupling with space-time itself. Dr. Laghari proposed a chilling possibility. If the field keeps reinforcing, he said, it might reach a state of harmonic equilibrium, a standing wave that exists through the entire planet. That's unprecedented. Meaning what? Lena asked. Meaning the Earth could briefly become a single, coherent resonator. A body-wide harmonic emitter. Emitter of what? He hesitated. Energy. Or information. At 2:14 Universal Time Coordinated, the Lumina frequency peaked. The resonance field achieved global coherence for exactly 126 seconds. Every monitoring station, every magnetometer, every deep-sea hydrophone, every satellite sensor recorded the same waveform, identical in phase and amplitude. For those 2 minutes, every system on Earth resonated as one. And during that window, something extraordinary happened. Above the Mariana Basin, the ocean's surface flattened. Completely. No waves, no motion. Just a mirror of absolute stillness stretching for miles. Then, from that silence, a vertical column of faint, luminous vapor began to rise. No light source, no heat, just luminescent mist coiling into the sky like breath in cold air. Orbiting satellites captured it, a pale thread reaching nearly 20 kilometers high before dissolving. Spectral analysis showed no known chemical emissions, no thermal signature, just ionized water vapor perfectly pure. The Lumina field subsided 2 minutes later, collapsing into a diffuse background hum. Energy levels normalized. Communications returned. The world exhaled, not realizing that something had changed. Because beneath the Pacific, sonar arrays began detecting new, stable echoes coming from below the oceanic crust, deeper than any natural structure could exist. They formed a regular lattice pattern, just like the resonance geometry mapped in the data. It wasn't seismic reflection. It was construction. In the days that followed, governments issued cautious statements calling the event a rare ionospheric disturbance. But privately, every major scientific agency on the planet began coordinating through encrypted channels. The Helios division received one such directive. Maintain full-spectrum surveillance of the Mariana Basin. Effective immediately. Lena stared at the encrypted feed from one of the deep-sea probes. A faint oscillation ran through the audio channel, the 21 Hz tone, soft but steady. She turned up the gain, watching the waveforms dance in perfect rhythm. It wasn't random. It was counting. 3 pulses. Pause. 3 pulses again. The same pattern as the very first signal from beneath the Greenland ice. The same heartbeat, only louder now, closer. The planet has learned to speak, Lena wrote in her log that night. But we still have no idea what language it's using, or who it's speaking to. The message beneath the waves. The order came at dawn. 3 autonomous deep ocean probes, Okeanos 7, Hadrian 4, and Tethys 1, were to be deployed into the Mariana Basin from separate vessels positioned along the trench perimeter. Each carried a full suite of instruments: sonar mapping arrays, magnetometers, spectral imagers, and a compact neutrino detector prototype. All 3 were built to withstand pressures that would crush steel. None were built for what they were about to encounter. For 2 days, the surface teams prepared under tight radio silence. Even the ship's coordinates were encrypted and staggered by time delay. To the public, they were oceanographic research vessels running routine geological surveys. Only a handful of people inside the Helios division knew the truth, that they were chasing the origin of the planet's new voice. Dr. Lena Voss joined remotely from Darmstadt. Her role was analysis, but in reality, she had become the signal's interpreter, the only one who seemed to feel its rhythm rather than just measure it. As the first probe entered the water, she noted the instant drop in ambient noise. The ocean itself seemed to hush, as if aware of the descent. At 2 kilometers, Okeanos 7 began streaming sonar data. Nothing unusual. Sediment layers, basalt ridges, the familiar abyssal silence. But as it passed 5 kilometers, the static hum that had haunted the Lumina signal reappeared. Faint, pulsing, alive. At 6 kilometers, the pulse stabilized at 21.0007 Hz, exact to 5 decimal places. No natural phenomenon maintains that kind of precision. It's like it's waiting for us, Lena whispered. By the time the probes reached 10,600 meters, the signal intensity had increased tenfold. Hadrian 4's magnetometer began to fail intermittently, its readings oscillating between positive and negative polarity every 7 seconds. The neutrino detector on Tethys 1, not expected to register anything at all, began picking up faint bursts of high-energy particles, perfectly synchronized with the pulse. That should have been impossible. Neutrinos pass through the Earth unhindered. For them to cluster at a single point, something below had to be interacting with fundamental particles directly, not electromagnetically but quantum mechanically. Whatever was generating the Lumina resonance wasn't just physical. It was active. At 10,972 meters, Okeanos 7's cameras activated. The feed showed the trench floor, a barren expanse of gray silt illuminated by the probe's cold LEDs. Then, out of the haze, shapes began to emerge. Not rock, not coral, patterns, lines etched into the seabed, glowing faintly with bioluminescent light, geometric, recursive, spanning hundreds of meters. Circles nested within circles, connected by radial channels that shimmered with slow waves of blue luminescence, pulsing in time with the signal. The structure was alive in the mathematical sense, organized, rhythmic, aware. Lena watched in silence as the imaging software tried to classify what it saw. Failed. No biological database contained patterns like these. No mineral registry matched their spectral signature. Yet the formation emitted heat. Faint, diffuse, but rising from beneath the seafloor. Hadrian 4 maneuvered closer, switching to sub-bottom sonar. The returns were unlike anything in geological history. A honeycomb of cavities and conduits extending deep below the crust, arranged with unnatural regularity. Each cavity reflected sound waves at specific intervals, not echoing but resonating, amplifying the Lumina frequency in a self-sustaining loop. It wasn't just a formation, it was a device, or an organism, or both. As data streamed upward, Lena overlaid the trench geometry onto the global resonance map. Her breath caught. The lattice beneath the Mariana Basin matched the missing portion of the spherical field, completing it. The Earth's resonance grid was no longer partial. It was whole. Then something unexpected happened. The Lumina pulse began to change. Instead of the steady 21 Hz rhythm, the signal split, fracturing into harmonics that rose in pitch like a climbing scale. The waveform folded in on itself, forming complex interference patterns that defied Fourier decomposition. To the human ear, it sounded like a choir emerging from underwater, vast, low, and incomprehensibly deep. And within that resonance, a new structure appeared in the data stream, repeating intervals encoded with ratios that corresponded to prime numbers. "That's not geology," Laghari said flatly over the comms. "That's syntax." "You're saying it's language?" "No, I'm saying it's organized intention." Moments later, Okeanos 7's depth gauge began to climb. Not because it was ascending, but because the seafloor beneath it was rising. Slowly, silently, the trench floor began to shift. Dust clouds drifted upward like underwater fog, and from the center of the glowing lattice, a column of shimmering material began to unfold. It wasn't rock. It wasn't metal. It was translucent, like glass, yet fluid, as if it were solidifying as it moved. The probe's cameras blurred, overwhelmed by refractive distortion. Then the telemetry cut out. Static. Hadrian 4 switched to sonar. The returning image froze the entire control room. The column was hollow. Inside it, suspended in the dark, was a sphere roughly 30 meters across, pulsating in perfect rhythm with the 21 Hz frequency. Each pulse emitted a microsecond burst of electromagnetic energy strong enough to register across the global network. Every time it pulsed, the Earth itself seemed to breathe. "Whatever it is," Lena said softly, "it's using the planet as a conductor." "A transmitter," Laghari corrected, "or a memory." For 36 seconds, all three probes transmitted simultaneous readings. Then, without warning, everything went silent. Every instrument, every satellite relay, every seismic feed gone. The Lumina field collapsed into absolute quiet. The hum vanished from the air. Even the planet's magnetic flux flattened to baseline. It was as if the Earth had exhaled and stopped speaking. 3 hours later, data began trickling back from the deep-sea relays. Okeanos 7's final transmission contained a single corrupted data frame, a burst of visual static that, when decoded, showed one image before the feed terminated. A spiral of light, forming a pattern identical to the Greenland pulse geometry, only now complete, converging toward a single point at its center. Lena overlaid it onto the resonance model. Fit perfectly. The spiral's endpoint aligned with a precise location, the Earth's core mantle boundary. Whatever the Lumina field had activated beneath the ocean, it wasn't the source. It was a relay. In the Helios Division archives, Lena added her final note before the blackout order was issued. "We thought we were detecting a signal moving through the planet. But maybe the planet was never the transmitter. Maybe it's the antenna. And something below, or beyond, has finally started to call back." The core signal. For 79 hours after the Mariana blackout, the planet was silent. No pulses, no magnetic oscillations, just static, the kind of quiet that feels intentional. Then, at 3:22 Universal Time coordinated on the fourth day, every seismometer on Earth recorded a synchronized microtremor lasting exactly 0.864 seconds. No known geological event could cause such precision. And yet, every sensor from Reykjavik to Johannesburg logged the same pattern. A triplet pulse, repeating 3 times, separated by exact 21-second intervals. The Lumina frequency had returned. But this time, the waveforms didn't move through the crust. They came from below it. Deep beneath the surface, the core was resonating. Not the molten outer core, but something beneath even that. The data showed a radial emission pattern rising outward from the core mantle boundary, as if an enormous sphere inside the Earth had begun to vibrate in harmonic layers. Each layer emitted its own frequency, combining into a chord of impossible complexity. The Helios division's supercomputers struggled to simulate it. At full processing power, the model crashed repeatedly, not from overload but from mathematical instability. The numbers refused to stay consistent. Ratios fluctuated by infinitesimal fractions, as though the frequencies themselves were self-correcting. Dr. Lena Voss stared at the cascading data. It looked like a living heartbeat, not biological, but algorithmic, adapting to interference, maintaining perfect resonance despite Earth's chaotic interior. Somehow it was learning. "It's not just transmitting anymore," she murmured. "It's synchronizing." The first visual clue came from Grace 2, a gravity monitoring satellite in low orbit. Its instruments began detecting oscillations in the Earth's gravity field, microscopic but measurable. The fluctuations were strongest over the Pacific, then spread evenly across the globe, forming a perfect spherical pattern. When the readings were converted into a 3D model, they revealed something astonishing. A rotating torsion field, anchored at the planet's exact center, modulating at 21 Hz. Not only was the core vibrating, it was emitting structured gravitational waves, and each wave carried data. The Helios team spent 3 days decoding the modulation patterns. What they found defied classification. The sequence contained no language, no repeating syntax, no recognizable code, yet it was undeniably intentional. Its internal logic followed prime intervals, harmonic ratios, and fractal geometries that mirrored the mathematics of living systems. "It's the same architecture we find in DNA," Laghari whispered during one briefing, "except scaled to a planetary level." Meanwhile, phenomena began manifesting on the surface. Compass drift intensified. Migratory animals, whales, birds, even insects, began altering their paths in unison, as if following an unseen vector. In Greenland, the cryo-array sensors that had gone dormant months earlier suddenly reactivated, transmitting faint pulses that mirrored the core's frequency. Perfect temporal alignment, zero delay. It was as if every part of the Earth, from ice to magma, was now part of a single system, a single organism. And then came the visuals. High-altitude pilots reported faint light spirals forming over the poles, pale, translucent vortices rotating slowly, invisible to radar but visible to the naked eye. Satellites confirmed. Ionization layers in the upper atmosphere were oscillating in time with the core frequency, producing interference patterns that resembled fractal lattices. They weren't weather events. They were projections, the atmospheric echo of something deep below. At 1847 Universal Time Coordinated, Helios received an emergency transmission from the Chromatic Seismic Station, just north of the trench. The message contained only raw waveforms, no text. But when played back through an audio filter, it formed a low, rhythmic tone punctuated by 3 harmonic bursts. Lena realized instantly what it was, a mirror pattern of the Greenland pulse. The signal wasn't just emerging, it was answering itself. The planet was in dialogue with what no one knew. Helios convened an emergency analysis session. All available data, seismic, electromagnetic, gravitational, was synchronized into a single composite model. As the simulation ran, the global resonance field reappeared on the monitors, bright and unified. But this time, something was different. The field wasn't just surrounding the planet. It extended beyond it. A faint, spiraling pattern reached upward from the poles, expanding into space like an invisible filament. The waveform amplitude decayed exponentially but never vanished, continuing beyond the sensor range, out of orbit. The Earth was transmitting. To where? Asked Director Halder. There's nothing aligned along that vector. Not yet, Lena replied. The discovery triggered an unprecedented collaboration between space agencies. The James Webb Relay, positioned near L2, was redirected to scan the direction of the outgoing filament. For 3 nights, it recorded nothing unusual. Cosmic background, faint pulsars, empty dark. But on the 4th night, something shifted. At the exact moment of the next Lumina pulse, a narrowband energy spike appeared from deep space. Same harmonic ratios, same prime sequence modulation, only inverted. It was coming back. The universe had answered. Inside Helios, the signal was routed through deconvolution software designed for astrophysical spectroscopy. The wave unfolded into layers, nested frequencies, each carrying smaller, self-similar structures. No message in any human sense, but there was a pattern, a recursive geometry that mirrored the resonance map of the Earth itself. It was as though whatever responded was reflecting the planet's own signature, recognizing it, acknowledging it. It's like an echo, Lena said. No, Laghari replied. It's a handshake. For 21 minutes, the Earth and the unknown signal exchanged pulses, perfectly synchronized across astronomical distance. Then, simultaneously, both ceased. No residual radiation, no magnetic trace. Silence again, but not the same silence. This one felt complete. In the hours that followed, the global resonance field slowly dissipated. Magnetic flux normalized. Atmospheric ionization faded. By dawn, the planet had returned to calm, except for one anomaly. Deep-sea probes near the Mariana Basin detected a slow upward current of warm water, continuous, stable, and faintly luminescent. Inside the current, temperature sensors recorded a steady reading of 37.0 degrees Celsius. Human body temperature, perfectly constant. Lena wrote her final log entry that night, knowing it would likely be classified forever. Asterisk, we've always assumed intelligence arises on the surface, fragile, temporary, confined to carbon and air. But what if consciousness has always been deeper? What if the Earth itself is an interface, a vessel designed to awaken when the right harmonic key is struck? The core signal wasn't a call for help. It was a recognition. Something beneath us has always been waiting to remember itself. Asterisk, the Lumina field never returned. But on certain nights, when the magnetosphere is quiet and the oceans are still, sensitive instruments record a faint 21 Hz vibration beneath the noise floor, the planet's residual breath. No one knows what it means. Perhaps nothing. Perhaps everything. Because if the Earth was listening that night, something out there was listening too.